Alright, so in this video, I'm going to complete the last 4 FRQs that I put together based on what you are most likely to see on the AP Calculus exam. And so make sure that if you haven't already watched the FRQ videos for the calculator section, that you watch that and then come back to here where you can continue watching these, right? So in this question, most of the time you're going to be given a graph of f or f prime or whatever, and then they're just going to start throwing questions at you. And so in this one, we're told that f is a continuous function defined on this closed interval, and the graph g, which consists of 4 line segments, is shown above. And then we're told g of x equals the integral from 0 to x of f of t dt. And so in question A, it says on what open intervals is the graph of g concave up? And so to find when g is concave up, we need to find when the double derivative is greater than 0. So I need to find when g double prime of x is greater than 0. And so how do I do that? Well, we know that g of x equals the integral from 0 to x of f of t dt, right? So what is g prime of x? Well, g prime of x is going to be f of x, right? What is this? Well, the rule goes that when we differentiate both sides, we just bring down this top of the integral, being the x, usually it would be an x, and we put that into the t. Now, what if it was an x squared? Well, then we would need to use chain rule, so then we would multiply by 2x. However, here we don't have to do that, right? And then we find g double prime is just equal to f prime of x, and we want to find when that is greater than 0. Now, what would we do? Well, after that, we can just find, okay, well, the intervals look like they're -4 to -2. So -4 to x to 2, and then 2 to x to 6. This is where g double prime of x equals f prime of x is greater than 0. You could just say something like that, is greater than 0. And it doesn't really matter if you had put this as greater than or equal to, you will still get points on the exam for it. They don't really care about your intervals unless it's a specific question where that is important. Now, in the next question, we are asked, let p be the function defined by p of x equals g of x times f of x. Find p prime of 3. Please understand, this is product rule. So p prime of x is going to equal, I would take the g prime of x times f of x, so that's the derivative of the first times the second. And that's going to be plus g of x times f prime of x, right? So then p prime of 3 would equal g prime of x, which again, like I said in the last question, is just f of x. So we'd have f of x times f of x. And actually, let's just keep it at p of x right now, or p prime of x. Sorry, so p prime of x, and then I'll plug in the 3 after. And then plus g of x is the integral from 0 to 3 of f of t dt. And then what is this? Well, we'll just have the f prime of x, right? And so then p prime of 3 would equal f of 3, which looks like it is -3, right? So -3 times -3, and then plus the integral from 0 to 3, it is just the area under the graph. So it looks like we have an area here, and so that area is going to be a triangle. So 4 times 1 times a half, so 2. And then down here we have this area, that's another triangle, and that's an area of -2, right, because it's under the graph. And then finally we're going to have this area, and this is a trapezoid. The area of this is going to be 3 plus a half, so 7 halves, and that's also going to be negative. So the total area would be 2 minus 2 minus 7 halves, so plus -7 halves, and that's going to be multiplied by f prime of 3, which looks like here the derivative is just 1, right? The slope is just 1, rise over run is 1, right? So we would have equals 9 minus 7 halves, and that's going to give me 5. It's going to give me 9 minus 3.5, so 9 minus 3.5, and that's going to give me 5.5. So my answer there would be 5.5. Now for part C, we want to find the limit as x approaches 2 of g of x over x squared minus 2x. And so here what we need to do is first evaluate this limit. So the limit as x approaches 2, and I'm going to do this of 0 to 2 f of t dt over x squared minus 2x. Well, what is the integral from 0 to 2 here? Like I said in the last problem, this area and this area cancel each other out. So that's 0 over, we would have 2 squared minus 2 times 2, which is 4 minus 4, or 0 over 0. And now we can use L'Hopital's rule. We have to first check this just in case we didn't get something that allows us to use L'Hopital's rule. Usually we will be able to, but sometimes we can't, okay? And so now if we differentiate this top, it just becomes f of x, right? Just like I explained in the last question, over if we differentiate the bottom, it's 2x minus 2. And we want to find the limit as x approaches 2 of this. And so the limit as x approaches 2 here would be f of 2, and f of 2 is negative 4, over 2x minus 2, which is going to be 2 times 2, or 4 minus 2, which is 2. So we'd have negative 2. So that's our answer to C. And so finally for D, we want to find the average rate of change of G on this interval, negative 4 to 2. And we're asked, does the MVT guarantee a value C for negative 4 to C to 2, for which G prime of C is equal to this average rate of change? Now, the answer is basically always going to be yes. MVT does guarantee a value C. On all the FRQs, it's always yes. Sometimes you have to use IVT, but again, it's always yes. It's usually just Y. Now, be careful. Maybe this year they'll change it. And just remember, in order for you to be able to use IVT, the function has to always be continuous. In order for you to use MVT, it always has to be differentiable and continuous, right? So let's take a look here. Well, what we need to do is we need to find our endpoints. So we have the endpoints of negative 4 and 2, but what are the y values? So g of 2 is going to equal the integral from 0 to 2 of f of t dt, right? And that's just going to equal 0 because, again, these two will cancel out. This and this will cancel out. So that equals 0. And the integral, or g of 4, is going to be the integral from 0 to 4 of f of t dt, and it's actually negative 4, right? So be careful. We're going to find this integral, or we're going to find the area under this graph, and so I'll just split it up into some triangles. This one would have an area of 2 times 6 times a half, so 6. Then this one's going to have an area of 2, and then this one's going to have an area of 1, 2, 3, 4, 5, 6, 7, 8. It's going to have an area of 8, and so this total area is 16. Be careful though, it's negative. And why? Why you ask? Because the area above the graph is positive. So why is it a negative integral? Because we're going from 0 to negative 4. We're going backwards. And when we go backwards, the integral becomes negative. So g of 2 would be or actually no, we would do, g of 2, so 0, minus negative 16, g of 4, over 2 minus negative 4, right? And so that's going to give me 16 over 6, right? And so once I get there, I'm going to do just 8 over 3, right? And so your answer then would be, let's write an answer here. Your answer would then be, yes, g prime of x equals f of x. You always want to add that, by the way. We do know that g prime of x is equal to f of x. And so we would say, we then have to say, okay, it's differentiable and therefore continuous, right? So g is differentiable and therefore continuous on the given interval. So the MVT, can be applied, and you could say guarantees that there is a value c on negative 4 to c to 2 such that g prime of c equals 8 over 3, right? And you don't have to word it exactly like I did. You basically just have to say the important parts here are that you don't even have to include this part, but that's kind of important. But what you have to say is g prime is differentiable and continuous, and then you say that you could basically just say that there is a value on the interval where g prime of c equals the average. You probably don't even have to drop the actual number. You probably get a point for the correct number, and then you get a point for this as well, the actual interpretation. All right, so continuing, we're told a bottle of milk is taken out of a refrigerator and placed in a pan of hot water to be warmed. We're told the increasing function m models the temperature of the milk at time t, where m of t is measured in degrees Celsius and t is the number of minutes since the bottle was placed. We're told m satisfies this differential equation, and told at time t equals 0, the temperature of the milk is 5. And then m of t is less than 40 for all values of t. We're told to use the slope field to sketch a solution curve through the 0.05. So they give us this point, and we just have to sketch a solution curve. So literally, this is all you have to do, and it's worth a point. It doesn't have to be exact. If you drew it like this, you'd probably get a point. Well, you have to make sure that it flattens out up here because that's like very clearly written. But if you drew it a little off, you'd get a point. All right. Now for the next one, using the tangent line to the graph of m at t equals 0 to approximate m of 2, find the temperature of the milk at time t equals 2. So for this, what we're going to do is we're going to write y minus y1 equals m times x minus x1. And what is m? Well, they told us that at t equals 0, the temperature of the milk is 5. So they gave us a point of 0, 5. So we're then going to plug this into our dm of dt to find our slope, right? That's going to be our slope. So dm of dt, and you could write evaluated at 0.4, is going to equal 1/4 times 40 minus m, so times 35, right? So that equals 35/4, right? And so then what we would do is we would plug that in to the equation we were given, right? So we would, or this equation, we weren't given it, right? So you would write y minus 5 equals 35/4 times x minus 0, right? And be careful, it's not y and x. You maybe still get a point for that. However, we need to be careful and use m and t, right? So it should actually be m, and then I'll write m equals. So m equals 35/4t, and then plus 5. Okay, and so we then have to use this to evaluate our point m of 2. So we're basically just plugging in 2 for t. So it would be m of 2 equals 35/4 times 2 plus 5. So it'd be we'd get 35/2 plus 5. And so that's going to equal, we'd get 22.5. Yeah, I think it's, 22.5, right? And does it tell us to approximate the temperature? Yeah, so just say degrees Celsius. Make sure if it tells you to like actually approximate something, you put the actual value, the actual unit. So continuing, we want to write an expression for d squared of m over dt squared in terms of m, and use d squared m over dt squared to determine whether the approximation from part B is an underestimate or an overestimate of the actual value of m of 2. And so what is d squared of m? Well, what we would do here is all we have to do is just say, all right, well, d squared of m over dt squared, it looks like we're going to have a product rule here is going to be, actually no, we don't have to have a product rule. Let's write that d, I'll write it up here. So let's write that dm of dt, we can actually just expand it. We could get 10 minus m over 4. And so d squared m over dt squared is just going to equal negative 1/4 times dm dt, right? You have to multiply by that dm dt because we are differentiating m with respect to t. Okay, so then what is dm dt? Well, it's this, right? So we'd have negative 1/4 times 1/4 times 40 minus m, right? And so you'd have negative 1/16 times 40 minus m. And it tells us that m of t is always less than 40. So if m of t is always less than 40, then this will always be negative. So we could write, since m of t is always less than 40, the d squared, I'll just write d2m over dt2 is always going to be negative, and therefore the graph is concave down. However, this is not exactly what it's asking for. It is asking us, did we make an overestimate or an underestimate? And what I like to do is I like to just draw a very obviously concave down graph. And so we knew the point here, okay? And we wanted to find the point here because we knew the point at t equal to 0, and this is at t equals 2. And we used a tangent line approximation. So here we could tell that it's going to have been an overestimate, okay? So it is overestimate. And so if you wanted to just see what an example of an underestimate would have been, if the graph had been this then it would have been an underestimate when we used the tangent line. All right. Finally, we need to use separation of variables for m of t and find the actual value. Now, this is usually when we use separation of variables worth like 5 points on the exam. Make sure you write out each step of these so that even if you get lost in translation, you get some points. So remember, for our separation of variables, we need to get the m on one side and the t on another side. So I'm going to say dm, actually I'll say 1 over 40 minus m dm equals 1/4 dt, right? And so now you would integrate both of them. And so then you would say it's going to be negative ln of 40 minus m because we have our 40 minus m in here. And then it's negative because there's a negative here, right? Remember that the derivative of ln is u prime over u, right? And that's going to equal, the integral here will be 1/4 t. Now remember to add your plus c. I like to just add it on the right side of this integral. It doesn't matter. And so now what we need to do is let's get m by itself. There's actually two things you could do. You could now plug in your initial condition and then find c. And that's actually on their grading rubric what they usually do first. But what I like to do is to actually get m isolated first and then I find c. So what we would do is we would say, okay, well, I'm going to get this negative to the other side and then I'll ln both sides. So it's just going to be ln of 40 minus m equals negative 1/4 t. And it's still just going to be a plus c. Okay, the negative doesn't make a difference there. So you would have 40 minus m equals, then you're going to e both sides. So e to the negative 1/4 t plus c, which then you would get 40 minus m equals ce to the negative 1/4 t. Make sure you understand how this c works. You basically, if you have a plus c in the exponent, you just bring it down. And so finally, you're going to get that 40 minus ce to the negative 1/4 t equals m. And so then we're going to plug in our initial condition, and we're going to have, I'll plug up here, 40 minus ce to the, it looks like our t is 0, so ce to the 0 equals, then our initial condition is m of 0 is 5. So it looks like we're going to have negative ce to the 0 equals negative 35. So it looks like just c equals 35. All right, great. So now we just plug it back into here. So we would write m equals 40 minus 35 e to the 1/4 t, right? And so that's our answer. Now, and it should be negative, sorry. Now, if we had tried to find our c once we got here, which again you could have done, you would have gotten that c is negative ln of 35. However, it does not matter. You can find the c after. All right. Now, for number 6, and it's actually number 5, there's going to be one more after this, we want to consider this curve, and it will usually tell us to just find dy dx. So this is going to be implicit differentiation. So here we're going to differentiate the left side using product rule. And so it'll be 6y, right, because the derivative of 6x is 6. I'm going to group the 6x on to the 6. And then plus, well, we leave the 6x and we differentiate the y. And so what is the derivative of y? It's going to be dy dx. Remember, if we're differentiating y, we do it the same way as x, but right after it, we always put a dy dx. And we're going to say that equals the derivative of 2 is 0 plus 3y squared, because again, we differentiate it the same way, but we have to have a dy dx. And so now we need to get dy dx by itself. And so what I'm going to do is I'm going to say 6y equals 3y squared dy dx minus 6x dy dx. And so then I could factor out a dy dx. So equals dy dx times 3y squared minus 6x. Finally divide everything. And so we'd get 6y over 3y squared equals 6x. And we could divide all this by 3. So you'd get 2y over y squared minus 2x. And that equals dy of dx. And that is what we were supposed to show, right? Now we're supposed to find the coordinates of a point on the curve at which the line tangent to the curve is horizontal, or explain why no such point exists. And remember, this is what we're trying to talk about. So 2y over y squared minus 2x. So 2y over y squared minus 2x equals dy dx. Now, when is the curve horizontal? The curve is horizontal when the top of the derivative is equal to 0. So when is 2y equals 0? That is when y equals 0. So that is all we have to do. Now, we need to be careful, and we need to make sure that we find that this is actually a point on the curve. So what we've done is we found that y is 0, but we need to find an x value that matches up with this. So we would then go back in here. We would plug in that 6xy equals 2 plus y cubed. So then we would get, it looks like we'd get 6 times x times 0 equals 2 plus 0. So we get that 0 equals 2, right? So this is not a point on the graph, right? This is not a point on the graph. So so the answer would be no then. No. Let's make this smaller. No, I'll just leave it because there is no point where the graph is defined and y equals 0. Just write something like that. All right, and your work would help you show that that's true. All right. Now for C, we're supposed to show if there is a point where the tangent line is vertical. By the way, they have asked this horizontal and tangent thing for both of the last 2 years in 2023 and 2024. So again, we're looking at 2y over y squared minus 2x. So 2y over y squared minus 2x. And so for this one, we need to set the bottom equal to 0. So we would say y squared equals 2x, where we should really write y, and I'll write equals dy dx. And so you have to set the bottom equal to 0. So y squared minus 2x equals 0. So I would then say y squared equals 2x. And let's just get x by itself. So y squared over 2 equals x. All right. And now what we need to do is substitute this in to our initial equation and find if there is a point where this is true. So we would say 6 times y squared over 2 times y equals 2 plus y cubed. You would get 3y cubed equals 2 plus y cubed. So you would then get 2y cubed equals 2. So it looks like y cubed equals 1, or just y equals 1, sorry. You would get y cubed equals 1, so y equals 1. And so what is our x value then? Well, the x value, so if y equals 1, then x equals y squared over 2, which equals 1 squared over 2, which is 1/2. Right? So you would get the point 1/2, comma 2, right? And so this is valid, right? This is valid. You would say the tangent line is vertical, and then you would drop the point. So at 1/2, comma 2, right? Continuing on. We're told a particle is moving along the curve. At the instant when the particle is at the point 1/2, comma -2, its horizontal position is increasing at a rate of dx dt equals 2/3 unit per second. And we're asked, what is the value of dy dt? Again, this was asked on this exam and last year's exam. This specific question is from 2023. So what do we do here? Well, we're going to use related rates with this initial equation. And so what we do is we would have, first you differentiate the 6x, right? We're going to use product rule here. So it would be 6y. But then you have to have that dx dt because we're doing related rates. Plus then you would have your 6x, and the derivative of the y is dy dt, right? And that equals 0 plus 3y squared dy dt, all right? And so we have to find dy dt. So let's just plug in everything we have. So 6 times y would be -12 based on this point, times dx dt is 2/3, plus 6x is 3 times dy dt. And that equals 3 times y squared is 3 times +4, so 12 dy dt. And so then we're going to get, we'd get -24/3 equals, 9 dy dt. So you'd get -8 equals 9y prime, I'll just say. So you'd get -8 over 9 units per second equals y prime. Right, so pretty simple. Now, on to the last question. We are given the functions f and g, which are twice differentiable, okay? And we are in the first question asked, let h be the function defined by h of x equals f of g of x, find h prime of 7. So this here, ladies and gentlemen, is some nice little chain rule. This is going to be this is like the filler question. This is not always the same, and so sometimes it's going to be the difference of areas bounded by curves. So the area in between two curves, it might be solids of revolution. It might be another table question where you kind of have to do chain rule. Okay, and so for this one, we have h prime of 7. Well, h prime of x equals f prime of g of x times g prime of x. This is the definition of the chain rule. Okay, so h prime of 7 equals f prime of g of 7 times g prime of 7. So what is g prime of 7? Well, actually, let's go left to right. So h prime of 7. So what is g of 7? Well, g of 7 is 0. Okay, so f prime of 0. Okay, and what is g prime of 7? Well, g prime of 7 is 8. Okay, so now we need to find f prime of 0. What's f prime of 0? It's 3/2. And look at how they do a wonderful job of giving you so many points where you really just are cooked if you do not know the chain rule. You're going to just have to pick random points here, all right? They don't give you any help. So 3/2 times 8, and then you'd get 24 over 2, which is 12, all right? And so then it says, let k be a twice differentiable function such that k prime of x equals f of x squared times g of x. It says, is the graph of k concave up or concave down at the point where x equals 4? So we literally just need to differentiate this function because we need to find k double prime of x in order to determine concavity. So k double prime of x would equal, so this is going to actually be a chain rule question. So this part is actually going to be a product rule inside of a chain rule. So for this first derivative, so we're going to do derivative of the first times regular of the second plus regular of the first times derivative of the second. And so the first one has to do chain rule. So we would do 2 times f of x, and then you would multiply that by f prime of x. Okay, and then we multiply that by g of x, right? And then plus, we just have our f of x squared, and then times g prime of x. So that's a lot, right? So now you have to plug in g prime of 4, right? So that's going to be 2 times f of 4 times f prime of 4 times g of 4 plus f of 4 squared times g prime of 4. And so all these numbers, right? So 2 times f of 4, let's be careful. So 2 times f of 4 is 4. So 2 times 4 times f prime of 4 is 3 times g of 4 is negative 3. And then plus f of 4 again is going to be 4, and we square that and we multiply that by g prime. So g prime is 2, right? So we would get 8 times, I'll do 8 times negative 9 plus 16 times 2, and so we'll get negative 72 plus 32, and so you get negative 40, okay? And give a reason for your answer. So this is less than 0, right? Again, we're trying to prove if g is concave up, or if k is concave up at x equals 4. So I would then write for my justification that since k double prime of 4 is less than 0, or I would write equals 4, negative 40 is less than 0, the graph is concave down at the point where x equals 4. Pretty simple. All right, continuing. Let m be the function defined by m of x equals 5x cubed plus the integral from 0 to x of f prime of t dt. Find m of 2. This is very, very simple. So what we would do here is we literally just have to find m of 2 equals 5 times 2 cubed plus the integral from 0 to 2 of f prime of t dt. Now, what is the integral of f prime? The integral of f prime equals f. Okay, it equals f. So here, m of 2 is going to equal, so for here we would just have 5 times 2 cubed is 8 plus f of x, or I'll just say f of t for the sake of this, from 0 to 2. Okay, very simple. All right, so finally we plug in our 0 to 2. So we'd have equals 40 plus, and then f of 2 is 7 minus f of 0 is 10. Okay, so 7 minus 10. So we'd have 40 plus negative 3, which would equal 37. All right, so lastly, we're told, is the function defined in M increasing, decreasing, or neither at x equals 2? So let's take a look back. This is our function. So let's just write this. M of x equals 5x cubed plus the integral from 0. This looks a little nasty. M of x equals 5x cubed plus the integral from 0 to x of f prime of t dt, right? And so we want to find if it's increasing, decreasing, or neither at x equals 2. So how do we do that? Well, that is the derivative. So m prime of x would equal, so we differentiate the first one, so that's just 15x squared, right? And then plus, well, what's the derivative of this? Again, this is now the third time on the FRQ we've had to use this fundamental theorem of calculus, where you take this x and you drop it into this little box, right? So plus f prime of x, right? So m prime of 2 equals 15 times 2 squared plus f prime of 2. And so it would be 15 times 4 plus f prime of 2 is what? Well, f prime of 2 is negative 8, right? So plus negative 8. And so you would get 60 minus 8, which is equal to 52. So then for our justification, we're going to say that it's increasing. So we're going to say, since m of 2 equals 52 is greater than 0, m is increasing at the point x equals 2. All right, so that was it for our video on the FRQs for your AP Calc exam. Make sure that you continue to study. We have unit reviews for every single unit, as well as we have another FRQ video besides the calculator one. We have another one of just straight up no calculator FRQs, as well as a multiple choice question video, as well as unit reviews for every single unit. So make sure you stay up to date, and good luck on your exam, guys.